Hello everyone. Welcome to this video lecture on the topic of Docker components. Myself, Dr. S. Ernagarapadines, working as an associate professor in the Department of Computer Science and Business Systems, Ramco Institute of Technology, Rajapalayam. In today's session, we are going to understand the core building blocks of Docker, how Docker works internally, what images and containers are, and how registries help us store and share containerized applications. By end of this lecture, you will clearly understand every component that makes Docker so powerful in modern DevOps and software development. First of all, we need to know about what is Docker. Docker is an open source engine that automates the deployment of applications into containers. It was written by the team at Docker Inc. Formerly, it was known as .cloud Inc. An early player in PaaS market and released by them under the Apache 2.0 license. Docker adds an application deployment engine on top of a virtualized container execution environment. Docker is designed to provide a lightweight and fast environment in which to run your code as well as an efficient workflow to get that code from your laptop to your test environment and then into production. These are the four essential components of Docker. First one is Docker client and server. Second one is Docker images. Third one is registries. Fourth one is Docker containers. In the next few slides, we will explore each one in detail with real life examples that make learning easier. The first component, Docker client and server. Docker follows a client server architecture. The Docker client is what you and I interact with. Whenever we type commands like Docker run, Docker pull, or Docker build, those commands are issued by the client. Next one, the Docker server. It is also known as Docker daemon. It is the actual worker. It builds images, creates containers, and handles all the operations behind the scenes. Think of it like this. The client is your Google Pay app. The server is your bank backend system. When you press send money in Google Pay, it does not send the money directly. It just sends a request to the bank server. Similarly, when you run Docker run command, the client sends a request to the Docker daemon to start a container. Docker also provides a full REST API, which means other tools and applications can talk to the Docker automatically. This is the Docker architecture diagram. This diagram shows how Docker's client and the server communicate. The client sends commands to the daemon, process them. The daemon uses these images. That images come from the registries, and then finally containers are launched from those images. You can run both the client and the daemon on the same machine, or run the client on one machine and connect it to a daemon running somewhere else, like a cloud server. The next component is Docker images. Images are the blueprints for containers. They define everything needed to run a piece of software like code, libraries, operating system files, and configurations. An image is built layer by layer. Each step might do something like adding a file, installing a package, or exposing a port. Example, you can think of an image like an APK file on Android or an exe installer on Windows. You installed the app on your phone or PC. That installation is like running a container. Another one real-time example. Imagine you want a Python application with Flask installed. You built an image using the following instructions. First one, the start from a base Python image. Next, install Flask. Copy your application and expose to the port like 8080 or 5050. Once you built the image, anyone in the world can use it to run your application exactly the same way. Images make your software portable and consistent. The next component is registries. A registry is like an app store for doc images. There are two types of registries. First one is public registries, second one is private registries. Public registries is open for everyone. Private registries, it's secure and restricted to your organization. The most popular public registry is Docker Hub, maintained by Docker Inc. The real-time example for registries. For example, if you run docker pull nginx command, Docker will download the nginx web server image directly from the Docker Hub. Docker Hub has more than 10,000 ready-made images like MySQL, Redis, Jenkins, Node.js, and many more. This is one of the biggest reasons Docker is so popular. Instead of configuring a server from scratch, you simply pull a fully configured environment in seconds. The next component is Docker containers. Containers are lightweight, isolated execution environments that run applications. If an image is like an APK installer, then a container is the installed app running on your device. Containers allow you to run software reliably across different environments like development, testing, staging, and production. Next one, Docker uses the same idea as real world shipping containers. A shipping container can hold anything like furniture, electronics, food, but the transport system treats all containers the same. Similarly, Docker containers may run different applications like database, web service, or machine learning API, but Docker handles all containers using the same operations like create, start, stop, restart, destroy. This makes containers portable, stackable, and interchangeable. One of the Docker's biggest strength is portability. You can build a container on your laptop, push the image to a registry, pull the image on a cloud server, run it exactly the same way. This eliminates the famous problem developers faced, but it works on my machine. With Docker, if it works in one place, it works everywhere. Final last one, the uses of Docker. The first one is faster and consistent development. Developers can build and test applications in isolated containers without affecting their system. The second uses running microservices. Each service runs in its own container, making architecture scalable and maintainable. The third one, continuous integration and testing. Tools like Jenkins use Docker to run automated test environments. Fourth one is replicating full systems. With Docker Compose, you can run multi-container stacks like a complete web application with front-end, back-end, and database. The last one, scalable production deployments. Modern companies deploy thousands of containers in cloud platforms like AWS, Azure, and Kubernetes. To summarize, Docker has evaluated how software is built, tested, and deployed. We explored Docker client, Docker daemon, images, registries, containers, and practical real-world use cases. Understanding these Docker components will help you work confidently with Docker in development and production environments. This is the reference book for Dockers. Thank you for watching this video.